I never know what to do with a lectern. You know, put your hands on it, put your hands in your pockets.
You have to do this.
Yeah, this. Ladies and gentlemen, boys and girls, welcome to the final and most amusing talk of the day, of the first day of Scala World, by Rory Graves and Sam Halliday. Yes, hello, I have actually started, no joke. So this is Rory Graves and Sam Halliday, for I think everybody knows them. I honestly think I am the only person in the room who I'm the person who knows them least in this room. Yet here I am telling you about them. They are the inseparable Scala talk duo, and I have researched for years and years, and I have finally stumbled upon work that they have done individually. Rory has founded Scalinator.io, which is a way for people to learn through an integrated, holistic experience to learn Scala. And Sam is, of course, Mr. Enzyme. Everybody knows this. And he knows his legal code very well, also, I've heard. So I'm going to stop saying anything for fear of being sued for what, libel or no, libel is written. What is it? Well, for fear of something. So, ladies and gentlemen, please give a warm applause for Sam and Rory.
Thanks, and I hope that was under a Libre license. Well, the intros. Well, the real TLDR of this entire talk is that people don't really test macros or compiler plugins in IDEs, and that results in a lot of red squigglies for people, and it means it's really nasty for end users, as in developers downstream of you, to use really intelligent macros and compiler plugins that could save you a lot of time. I personally end up just writing the long form of some things because it gives me IDE support. And we've written a library called PCPlod, which to the rescue, and it will help you to write tests in the presentation compiler. So everything else in this talk is building up to the point where we can really try out PCPlod, and it's kind of a bit of a side effect to write compiler plugins and macros along the way, in case you're not aware of what's going on under the hood.
You know what? No one's going to get that joke.
Yeah, I figured maybe 10% of the audience. There's an awesome picture coming, just for the...
So who knows who PCPlod is? So who's of a certain age?
Yeah. There is Mr. Plod later as well. So we're going to start off. Rory's going to talk about the key concepts inside the Scala compiler, and we mean the current Scala compiler. We heard from Martin today about what things look like in Dotty. A lot of things are really the same from the perspective of the tree, but there are some innovations there as well that we would have to account for later on when Dotty does finally arrive. Then he'll talk about compiler plugins, how to write one, the boilerplate you need in order to set up a project to write a compiler plugin and to be able to publish it and so on. Then he'll hand over to me and I'll talk about doing more or less the same thing but as a macro and talk about some of the more popular kinds of macros. Is there a problem with the video? I heard someone talk there. Then I'll introduce what the presentation compiler is and why we always care about it in ENSIME and for Scala IDE, and introduce PCPlod, the library, which is really quite simple. Then we'll have the workshop part of this. So hopefully everyone has a laptop or is sitting beside somebody who has a laptop. And our goal in that workshop is to basically try to re-implement case class as a compiler plugin. You could also write it as a macro if you want, if you prefer. There are tests around both of them. And then we'll sort of gather again and have some concluding remarks on that. So if you haven't already done it, please clone this project, Scala compiler plugin, and type in SBT update classifiers so that it has all your Java docs and sources and dependencies when it comes time to to actually write some code in that workshop. If you don't plan on having the Java docs and sources downloaded, just type SPT update. The tests will not pass because they will throw an unimplemented exception, which you will implement. Okay, so let's talk about Rory. Just to introduce Rory. He was writing mobile games before it was cool, whenever Snake on a Nokia was the height of technology. And he was working on dynamic networks long before clusters were cool. That was his PhD thesis. We've already heard about scalinator.io. What you might not know is that he is a trained martial artist and can wield a sword. And he has a 5-year-old son who's been singing Jingle Bells for the last 9 months. And if you want to find out how good of a swordsman he is, just try sneaking up on him and singing one of those songs. And it'll kick in pretty quick.
It's my turn to abuse Sam a little. So let's get the boring stuff out of the way. Sam, of course, is it Libra, Sam? Libra High School science textbooks?
That was before the Free Software Foundation changed the name to Libra.
What did Stallman say about it? Did he ask you to change it?
Yes.
So Sam was actually, in his history, actually key in generating millions of free textbooks in South Africa, which I think is actually really awesome. He's a chartered mathematician, whatever that means. Quantum mechanics he talks about, and machine learning and things. And he does mainly talk about Kerbal now, and apparently that's maths too. So if you want to get him going, talk about Kerbal. He wrote Netlib Java, which underpins everything nowadays. He's a free software. You may have heard that he thinks about, he cares about free software and Libra licenses. He is most proud of getting to the moon and back, for those that have played Kerbal. The slightly hilarious thing is he gave us this picture on the last talk to prove that he got to the moon. And about 3 days ago, it's a fake. Well, it could be a fake. The shadows are all wrong. The most hilarious part about this, though, is Sam successfully got his Kerbal to the moon and back with one fatal flaw. He forgot to add the parachute. So having successfully navigated to the moon and back, the Kerbal had an unfortunate demise with a very fast impact with the planet. So, quick show of hands, who uses IntelliJ? Everybody, right, okay. And Scala IDE? Okay. Oh, poor Scala IDE. ENSIME? Hey! Anything else? Yeah. Well, ENSIME's Vim, you can use.
I was trying to convince him early. I think we're almost there.
We're almost there with Miles, are we? And who has written a macro? Whatever you like. Who's written a macro after the previous workshop? It's like compiler plugin. Hey. Still fine. That's fine. A presentation compiler test for the above. And who's seen red squigglies in their IDE? Yeah. So this is the thing that we're trying to address a bit, trying to make a bit better. Basically, because of the way the presentation compiler works and because of what Scala IDE does, or because of what IntelliJ does, you often see red squigglies on perfectly valid, semantically correct code, and we want to fix that a bit, or to at least try and address it for plugin authors. So, next I'm going to talk a bit about the compiler AST. This seems a bit moot, having just spent the day listening to people talk about the compiler AST, so I'm going to be fairly brief. So, first up, symbols. What's a symbol? Symbol simply a binding between a name and an entity in the compiler. So these are just the key concepts. You need to have at least a handle for what they are when you're writing macros and plugins. So anything you can define and give a name has a symbol in the Scala compiler. Class, object, trait, vals, vars. One thing to be aware of, it's not just a name, it carries other information about the symbol. So for example, type symbol represents types, classes, traits, and type parameters. As I say, this is going to be a whistle-stop tour. Do stop and ask questions, and I'll refer you to Eugene like everybody else has today. Class symbol obviously represents classes and traits. Name, the modifiers, base classes, type params, da-da-da-da-da. I'm not, I'm teaching grandma to suck eggs here, I think, so I think that's a fair summation of the room. So term symbols represent vars, object declarations, packages, value parameters. So this isn't, I'm going to rapidly go through this because there's no point telling you all about this stuff. I just want you to, if you do have a question, do ask. So a method symbol does exactly what you'd expect. Types. We've talked about types a lot. Right, so trees. Everything in the AST is a tree. So you've got types, terms, trees. So the key thing is, if you're writing normal Scala, you will not really recognize any of the stuff on the bottom row. If you've ever written a compiler plugin without using quasi-quotes, or even if you have used quasi-quotes, I suspect you start to come across this stuff. One of the key ones that a lot of people aren't aware of is position. Everything on a compiled source has a position. One of the problems is that when you create macros, they often don't carry the position information, which is one of the things that screws up the presentation compiler, because when there is an error, it doesn't know where to report it against. So it's fundamentally, it's exactly what you think it is. It's a point in your source code that AST is referring to. One key method when you're writing this stuff, tree with pos, you can actually set the position of the stuff within your macro or within your compiler plugin. And it lets them report the errors in the right place, and it works for both macros and plugins because fundamentally you're editing AST and it's the same stuff. Quasi-quotes. Quasi-quotes are cool. There you go, Eugene. What more can I say? They're a nice way of writing AST, but that's one thing to be aware of. It may look like Scala code, but it is not Scala code. What you're doing is it's a textual representation of AST. And it's a subtle description until you start to have to debug this stuff. And because of that, there are some gotchas. So here, if you looked at this in raw code, if you looked at this as simple source code, the code this is representing and the code it would output, term and class.name are the same string. They represent, to us, they represent the same thing, but they have different types. One's a class def, and one's a term name. So when I started playing with this stuff for this talk, this is one of the things that caught me out. I get very easily confused, as most of you already know. So one of the key concepts that you also need to be aware of is the Scala compiler is built out of dependent types. Everything under the hood is built out of dependent types. What this means is you can't just go anywhere, you can't just go new term, you need to be in the right scope. And pretty much everywhere you need to do something akin to that in this kind of code. So, any questions about trees, symbols, types? I know that was a very, very brief introduction. No, excellent. That makes it easy. So, compiler plugins. Who's seen this list before? Everybody in the room, right, good. I've skipped 3/4 of the middle. But A compiler plugin is basically another phase. You need to fit it into this list somewhere. The key phase here, obviously, parser, taking your raw source input and turning it into an AST. And the meat of any compilation is the typer. That's where most of the work is done. So that's applying the types to the tree, and we've talked about this quite a lot today. And then there's all the various translations, all the cleanups, and then actually spitting out code at the end. So how hard is it to write a compiler plugin? It's easy. Well, ish. And I'm going to go through these phases and give them a bit of description, but you need a definition, description, a component, a phase. You put it all in a jar and you add it as a dependency. It's a whole bunch of standard boilerplate. So let's walk through the boilerplate you need for the data plugin, which is what we're going to use as an example later on. So, @data is a customizable case class. We'll talk more about the idea behind it, or why you might want to re-implement case class a little later. So the plugin descriptor, it's a lump of XML that just tells the compiler where to find the plugin. The plugin gives it the name, a description, and the components of the plugin. So I'm going to do stop me if you have questions, but I'm just going to black through this. The plugin component actually defines where within that set of phases the plugin actually runs, and then you define the phase which actually does the work. So that was easy, right? We've written a compiler plugin. Doddle. Put a print line in there, I've successfully written a compiler plugin. The gotcha is the bit in the apply method is actually quite hard. Actually generating trees and manipulating them and the rest of it is quite fiddly, as you will find out. So what do you do once you've done that? You throw it all in a jar and then you add it to your build. That really is it. It's actually amazingly simple to actually get on the run. I think you can do it. I think there is a way of doing that. I discovered today, obviously after writing the talk. Yeah, that was the main way I found described. I think there is a way of doing it interactively, but I'm not actually. I'll ask Eugene. Eugene? Can you write a compiler plugin directly in source without having to package it into a jar? Class files.
Well,
What? He doesn't know.
well, actually, you can. Why not?
There you go. You can.
It's actually the trick here is, as far as I remember, is it is possible to put class paths after the colon X plugin, but you need to make sure that the plugin manifest is actually either first in the class path or the last one. I don't remember the details. At some point, I got really sick of packaging stuff into jars, and then I hacked that.
Okay, so yes, it can be done. So that's my bit done. I'm going to hand over to Sam to talk about macros.
Right. Def macros are the canonical macro, really, and I've picked one here just from SLF for S, which is the thing that gives everyone a performance benefit in their code base. If you're not already using it, please pull it in or take the code and use it as part of your code base. So the idea here is, up at the top, we're just writing reasonably standard, we're defining a standard Scala method on a normal class, which is we're calling logger, and it takes in an SLF for JLogger. And we want to just re-expose the methods on the logger, such as info and warning and so on. So we're defining the info that takes a string and a throwable. But what we really want to do is we want to check, does this logger have info enabled before we log out an info message? And for all of them, and especially down the debug level, because it can actually be quite costly to construct a string. And if you use, say, by name parameters, you'll still create an object even though you're not logging it out. If you were to write something, for example, that took in a by name string and a by name throwable, and then tried to work out later on whether or not debugging was enabled or not. This is a feature that you can only really implement by writing out the boilerplate or rewriting it with a macro, so that the macro writes that boilerplate for you. So once we've defined our method, which is just standard Scala, we then have on the right-hand side, this is where we pull in the macro. So we just declare a macro and we call out to something which is the implementation. We put all the implementations on this other object over here. And all the macros always take in this kind of pattern of inputs. The first thing is the context, which here is a black box context. I'll explain the difference between black box and white box in the next slide. And then we take in the AST representation of the parameters to that method. So up here we had string and throwable and returned unit. Here we're taking in an expression of string, which is a dependent type on the context, and a throwable and returning unit. And like Rory said, we always have some variation on the pattern of import global dot underscore. Here it's c.universe dot underscore. It's just the difference between the macro and the compiler thing, but actually it really defines more or less the same objects. And that's pretty much what Martin means whenever he says that a lot of the internal details of the compiler have been exposed, such that macros really are the compiler API. So once we're in here, you could drop it, you could take that code and drop it into a compiler plugin. It's really using exactly the same API. And we're using quasi-quotes here. So the first thing we do is we go and we get the underlying of the C here, which was the, from the context. So what we can do there is we then say, if info enabled, which is the underlying up here, by the way, in case you're trying to work out which thing that refers to. Oh, there's a typo. I've introduced a typo, haven't I? The c.prefix is not, is that the right thing? No, it is. That is the right thing. I'm okay. C.prefix is the underlying here. So then we can ask, is info enabled? Which is the check we wanted to do at the call site, where we don't want to do anything unless info messages are enabled, because constructing this string is the expensive bit. And potentially constructing the throwable is the expensive bit. So we'll only execute this code if this really is enabled. And that's it. So every time the user calls into this code, it really gets delegated to this macro, which generates boilerplate for them, which is generated from this template here. There's a couple of gotchas. First thing is you can't use this in the same compilation unit as where it's defined. Typically, people would have a package called macros as part of their project where they would throw all these things, and that's one way to get around it. That's pretty much the only really bad thing I know about black box macros. So that was black box. What about white box? So black box, the reason why they call them black box is because they faithfully follow their type signatures. So everything about the types of this code are defined up front. You know exactly what you're getting in, and you know exactly what you're getting out, and you will get a compile time failure if this does not return what you expected. This is not such a good example to explain maybe a white box macro, but what a white box macro could do is it could return something that was more refined than this. So it could perhaps return some kind of dependent, perhaps some kind of singleton type or something, which is maybe even based on the string that it's passed, potentially at runtime even, because we have these things called type provider macros, where they really can generate entire ASTs from basically a string. You can define a database schema, a type-safe database schema from an XML file or some kind of DSL string. And they're always white box because they do not have to return precise signatures. So things get out. I think the definition of white box is maybe even a wee bit wider than that. It's more or less you can rewrite your entire program, or you can at least rewrite the entire compilation unit with white box, more or less. There are some restrictions where you would need to drop down to a compiler plugin, but you pretty much can do whatever you want in them. Whereas the black box ones are much more rigorous, more well-defined, and I should like to think that whenever we get Dotty, that the black box API does not change that much. Would that be fair to say? you're not committing, but it would be hard to get rid of these entirely. So if you're writing black box macros, I'm perfectly fine with those. And I think if you need to write a macro or a compiler plugin or something that's in the meta space and there's not an existing library that you can use that does it, don't be afraid to write a black box macro to do it. They're there for it. But always be a little careful if you then need to go into the white box world. And the big thing that people really want to do with white box macros is the annotation macros. So you can define some annotation. Here we're coming up with one called data. I wanted to call it case, but because case is a keyword in Scala, we can't have an annotation called case. So we're going to have to survive with just data. And you can define this as having a macro transformation on it. So that you must follow this pattern when you do that. And what will happen is when the compiler hits any classes or traits or objects that you've defined, any element, as far as I'm aware of, there might be some restrictions on what you can't put an annotation on. It will call out to the method that you've defined here, which can effectively just write whatever it wants at that call site. So here our imports are to pull in everything from macros. And we're also using a slightly different pattern here. Like, you don't have to use this style. If you remember in the previous slides, I showed you that the first parameter list you pass in the context, which here is black box, but we're changing it to be white box. You can have an alternative style of writing your macros. They're called bundles, which means that you don't have to write that. If you're going to have lots of these things, like bang, 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 you can, rather than making this an object, you can make it a class and take in the context right up at the top. So you can do one import, and that means you don't have to repeat this boilerplate every time. So that's quite nice. And then here we have the same kind of list again. So we've got our annotees, and there are some reasonably complex rules about what gets passed to you here. For example, if you annotate a class and there is a companion as well in the same compilation unit, you will be passed not only the class, but you will also be passed the companion AST, so that you can do things with both of them at the same time. And then we return another expression, and these really are any. You can do whatever you want with them. And there's some more complicated rules about what you can be passed here, but we'll just assume that we're dealing with things where we're adding in one annotation on one class or trait, and we're effectively, you just map through the whole thing. So what you can do here is you can go in and pull out all the trees that represent those expressions. We get them into a list. And then, this is where the dragons are. We do whatever we want, and then we return back an expression, which is effectively a block of Scala code that does whatever you want in there. So that's why these things are considered very magical. They can really do anything. Talking about compatibility, so Macro Paradise is kind of the bleeding edge version of the Macro API. It lets you do more things than what's already bundled in the standard Lightbend Scala compiler. But it also allows some of the features that are, say, in Scala 2.11 to be backported to 2.10, but not all of them, which means there is a little bit of a compatibility problem. And if you're trying to cross-build your code, like maybe you're writing a library, you have to be careful that you're doing something that you can actually accomplish on the versions of Scala that you're cross-building for. And to help with some of the more practical matters of that, there is Macro Compat, the deal, and I think Miles might have been involved in, which help the cross-build of shapeless so that you can use this common API. I think we're using Macro Compat in the exercise material, but just to keep things simple, we'll just stick with Scala 2.11 for today, and that can be left as an exercise for later. But Macro Paradise does give you access to a few extra things that the stock one won't allow. For example, the annotation macros. Eugene points out that you do need to have Macro Paradise in order to be able to do those. Right, and IDEs. I mean, the thing is, these macros have very limited ENSIME and Scala IDE support. And black box def macros don't cause any trouble. Typically, you define one of these things, and as far as the IDE is concerned, it's just a normal method, so you can call it and there's no problem. But there's also limited IntelliJ support. And for those that don't know, ENSIME and Scala IDE are both using the real compiler in interactive mode, but IntelliJ have gone and effectively re-implemented the entire AST. They've basically written their own compiler for Scala just for the presentation aspects of it. And their support for macros is different to the support that the actual compiler has. We've seen today the ability to expand some macros, but in my experience, most macros just give red squiggly lines for everything. So there is very limited support there. What is the PC? And I've already mentioned it's an interactive mode of the Scala compiler, and it's used in ENSIME and Scala IDE. But what's it used for? It's used to answer the question, what is the type or the symbol at point? Those trees that Rory was talking about earlier. It gives you access to that when you're editing your code. And it also gives you semantic highlighting, the position in your source code of what is a term, what is an expression, what's representing a type, and what exactly is it, what does it expand to after naming has been provided on it, and what's the inferred type of things where type inference is expected. And the way it works is it keeps everything in memory. It's kind of funny listening to how Dotty's being designed. It's almost like Dotty is being designed from the beginning to sound like what the presentation compiler of the current Scala compiler is. So the Scala compiler is typically in batch mode, right? You pass it a bunch of files, it takes in binaries, compiles them, and chucks them out. It's very, very much a linear process. The presentation compiler is kind of in a constant loop, where it has access to some binary files, which may or may not disappear, or new ones will be created throughout its lifetime. And you can make it load Scala source files or unload Scala source files as the user is adding or deleting files or renaming files. And every time you add a source file in, it will parse that file. Every time you make a change to that file, it will reparse and retype check that file. So you'll find that one way of getting a big performance gain in Scala IDE and ENSIME is to always constantly compile your project in the background, or make sure you compile it after you make any big changes, so that it only loads the files that you're interested in changing, only recompiles those interactively, whereas it's really relying on the versions of the files that the real compiler has, the batch mode compiler has produced already, so that it doesn't duplicate work. But it can sometimes get confused, especially if binaries start arriving or deleting. So what we all typically do in the tooling space is we just bounce the presentation compiler. If any of the binaries that it's relying on have gone away or new ones have arrived, just throw it away and start a fresh one, so that it always has a clean binary class path. But even in source mode, it still gets confused. It'll see relics of objects that were defined in other files, and it just gets very, very confused. And you can only really solve that by restarting it. And it was designed with performance in mind. And it makes a lot of, there's a lot of places where it trades correctness for performance. The most obvious way of doing that is by skipping the later stage of compile. You don't need to output Java bytecode in the presentation compiler. So just don't do it. But that has some unintended side effects, because some work in the later stages of compile are doing things like auto-tupling. And by not having auto-tupling, it means that some code that you can see that compiles perfectly fine, the presentation compiler thinks, oh, well, you've given me a tuple, and I expected it to be a method call with a tuple, something like that. So you get lots of little false positives like that I would really like to fix. And it takes some shortcuts. So I learned last week that if you write list bracket bracket, there is a part of the typer phase in the compiler that will replace that with nil for performance reasons. Because if you call list bracket bracket, there's an array and all sorts of things called. There's loads of object creation. And they realized that this was a significant contributor to the compiler performance inside the Scala compiler itself. So they replaced it with nil, unless you're in the presentation compiler. And that sounds like something that shouldn't have any unintended side effects, right? Unless you're doing some kind of singleton type thing where you wanted list : dot type, which might work if you're relying on the compiler, but the presentation compiler gets completely confused because it's not doing this replacement. So you have to be aware of the hacks that it's doing, and therefore what flavor of Scala is not going to work, and you're going to get red squigglies for it. It also seems to have a different search space for objects and finding methods. I don't even understand where it's going wrong, but it's something I'd like to investigate, because it does impact me. And you end up having to open up more source files than you really should in order for it to understand what's available. And of course, it's single-threaded and compiles a full file at a time. So if you're editing a really big file, like defaults in SBT, you can wait 5-10 seconds for it to type check that file every time. Or if you've got implicit derivations, if you've got some really, really big ADT in shapeless, you can be waiting a long time, just as long as you would for the real compile, for it to work out some implicit that you don't actually really care about to get your completion. And there's no way to stop it when that happens. So, you can try to restart it and start a new one, but that old one's still going to run until completion and eat up CPU cycles while you're waiting. So you really have to care about performance a lot more than you maybe would with a normal compiler. And there's this concept of the position in the trees in the compiler, which relates the AST to a line and a file in your source code. And that's absolutely essential in the presentation compiler. Trees are useless without position, because the kinds of questions you're asking of the presentation compiler are, what's the type at the point? Give me a completion here. What's the symbol at point? And if you don't know where anything is, you can't answer those questions. And people don't tend to think of preserving position information whenever they're writing macros and compiler plugins, because you've got your functional tests of what you want your macro to achieve, and the position information is completely irrelevant to actually achieving that goal. And you would only really notice if you did a manual testing phase where you were using your own macros and going, oh, I'm getting red squigglies. But what ends up happening is that downstream users end up with a lot of red squigglies. So the kinds of failures you get, it'll just fail outright in some cases where position information is overlapping, which can happen if you just copy the position from if you're maybe, say you're creating a companion object and you just copy the position information from the class onto the companion, now you've got overlapping trees. And the presentation compiler, it's not happy with that at all. So what you have to do is you have to come up with a transparent position or do something slightly different. Not having any position at all is almost as bad. It says, I need to have position information for this tree. Which ultimately means that people downstream of you might not want to use the library because it just introduces more pain than what it would have saved in the first place. And I personally think that the SBT TSL, which is really nice, the macros need to be fixed to work inside the presentation compiler, because I can't use the DSL because I lose completion in all my plugins, not just around the macro, but in the whole file. Therefore, I will personally write more boilerplate just to get completion, which is nasty. So sometimes what I'll do is I'll write a plugin for SBT using the standard Scala API, and then afterwards go and write it to be the DSL so it looks nice and pretty. But actually my development process was using as much non-macro code as I could so that I got the tooling support until that point. So the kind of bugs that you might have in your macros or plugins, failure to preserve mutable information on tree. It's not just position. There's other stuff as well. There's modifiers and there's a few other things there. Types, if you copy a type, but you just copy the type by reference, not copy it deeply, you can end up with that being changed later on in another context that you weren't expecting, and it can blow up. So when you're doing that, always prefer using global.treecopy._ to copy trees, rather than the .copy method that's on the tree directly, because they're all case classes. But the .copy method will not copy over the mutable state. These things will. And I've already mentioned that some mutable state can be mutated in some other phase later on. So it's not about concurrency. It's really just about escaping of scope. And like I mentioned, try to preserve the position information. But if you're generating a completely new tree, a new expression, you must add transparent position onto it. Otherwise, the presentation compiler just doesn't know where it is, literally. Okay, so to address some of those common pitfalls, these are two little helpers that I would encourage you to use. Question?
Question for you two, actually.
Well, actually, classicals are completely positions. So it's they are mediated itself or converting scala symbols.
No, I appreciate that, but I mean, why is there any obstacle for the slide that Sam just flipped away from?
I would actually like to know the answer to that as well, because I do have a test for it that was written a few hours ago, and we can run that. But I'd also like to know what quasi-codes does in terms of positions. I don't think it puts no position on them because it would fail.
Oh, it does.
Yeah. Oh, did you update that test case to include?
No, I haven't yet. But,
Okay.
That's for sure. So quasi-codes don't do this in special positions, at least in Scala.
Okay, so you might need these hacks even if you're using quasi-codes then.
Yes, that's right.
Yeah.
Why couldn't that just make it into mechanisms just to do that by default?
So what do quasi-codes do? If you write queue of some piece of symbols.
Like it's just exactly what Sam's got on this line.
Yeah. This actually that's not necessarily true. So this is kind of a big hammer. Let's just focus on this second implicit class here. And the Lisper inside of me has realized that the brackets don't count. Same in every language. So what we're doing here is we're just extending tree so that we have this extra method that says with all the positions. And we're passing in some example position. So this example position might be from, say, some class that you've annotated. And what you want to do is you want to go through every single tree that you've just generated and pop a transparent position on it. And this is actually wrong for a different reason that I'll talk about later, to do with compatibility. This will only work in Scala 2.11. But we're going through every single one the whole way down the tree, which is what for each does. Now let's say you've got some macro where you're taking a block of code that somebody's written and wrapping it with some, I don't know, loan pattern or something like that. If you were to apply this, you'd just whack out all the position information all the way down. So you'd need to be careful in that case that you only add transparent positions to the parts of the tree that you've added, not the bits that you've moved around that the user has already defined. Otherwise, yes, but if you were to apply this way, you would just erase them all, even if you copied them afterwards. And there are some other holes in the compiler API where, for example, if you're modifying if you want to change the modifiers that are on an annotation, and we have an example of that, it doesn't copy over all of the mutable information. This is probably a bug in the compiler API as far as I'm concerned. So it's hopefully something we can maybe address at some point. And you only really discover these things whenever you're running them through a presentation compiler test, because you wouldn't care about that sort of thing if you just wanted the functional aspect of what the annotation does. So this is PC Plod to the rescue, right? So we've created this library which allows us to write these tests, so we can actually find these bugs, and we don't have to get users reporting in bugs saying, I had some code that I can't share with you because it's my company's code and it goes all red squiggly. What can I do to help? And first thing you want to do is say, well, can you create a reproduction for me? Which usually involves download this version of Scala IDE, load this project, navigate to this file, compile it. If it's not read, then clean it and maybe open it up again. It's just really, really complicated. So we came up with a really simple API, just using the loan pattern. Works in any kind of testing library that you want to use. We say with PC Plod, and we get handed a PC Plod instance. And on that, we can say, load me Scala files at this location. And these Scala files you just put into your resources directory of your test, into the resources directory, not into the compiled code. So you're putting source code in resources, which is kind of weird. Might mean you don't get IDE support in those files. And then you can write some tests in here, and I'll give you examples of the kinds of tests you can write. First one is symbol at point. So given the name of a resource, like this is a resource here, so some path to foo.scala, given a point, give me back as a string, because we don't necessarily really need type safety here. It's people writing tests where they really are ultimately asserting on a string. So that you can say symbol at point in this file with this position is some fully qualified name. And then type at point, which is the other one. So you can have some point that you care about and ask for the name of it and the type of it. And you can also ask for all of the messages, which includes all the error messages. to be honest, if everyone in this room who has a library just wrote a test that opened up a standard idiomatic file that exercises their library and asserted that that messages list was nil, I think we'd score so many bugs if we could get to the point where we could just get rid of that. And this kind of stuff usually just works if the message list is nil. So this is really the important thing. And point, you don't need to construct a point. We've got some implicit, so you can pass in an int, which is just the number of characters into the file. Not necessarily tested on Windows yet. Version 2. Or a tuple of int, which will actually fail if you use that notation in ENSIME or Scala IDE because of the auto-tupling not working. So maybe we can fix the presentation compiler to solve that one. Or write a compiler plugin that sort of deals with it. Or a symbol, using what we call naughty syntax. And this is where all the British people in the room should laugh, and Irish. This is what naughty syntax looks like. This is naughty for the people that don't get it. I can tell there's at least 2 people. This is naughty, and this is PC Plod, and this is Big Ears. I can't remember this character.
And which one is syntax?
This is syntax, the bear. Naughty syntax is just like this. So we have ats on either side of a name, and they're just completely removed from the source file whenever we load it into the presentation compiler. So you could write code like, for this resource, get me the type at foo, and it should return what the compiler wants to do there. So what about IntelliJ? Most people put their hands up for IntelliJ. Well, they've got their own system entirely. They don't use the presentation compiler. My hope is that if we can all write better macros with better position support, things should just get better for IntelliJ as sort of a base level. Because if they're making assumptions about how specs work, and they might actually have some kind of parsing of the positions, then it might just get better. But they have their own framework for writing plugins to IntelliJ to effectively duplicate the work of macros and compiler plugins. So you have to write it again, is what it boils down to. And I've seen that with libraries like Simulacrum, where they release the Simulacrum library, which has macros in it, annotation macros, in fact. And then there's a corresponding IntelliJ plugin, which often gets rolled into the standard Scala plugin for it. And that will detect when you're using a Simulacrum macro and rewrite the IntelliJ AST. A point to be made by IntelliJ, I think. Ah, okay. So for people who didn't hear this, it sounds like there are some plans that allow people to package an IntelliJ plugin with your library. Yeah. And you would have to use this API. Yeah, you have to use this API. Yeah. You just have to package a small Excel file which describes which classes the plugin for the plugin should be used. Right, okay, so you can use the compiler plugins now, as long as you know which ones to use. No, it has to be an IntelliJ plugin. Okay. Okay, so it sounds like there's some efforts there to help unify this, but it does, if I'm getting you right, you do still have to write additional code using this API. Do you have a testing framework for that? Because people that don't use IntelliJ would not be able to tell whether it's working or not.
Unfortunately, this whole new API was a little bit abandoned.
Okay, the API is abandoned. That's a shame. Okay. Yeah. So it sounds. Okay. Yeah. It's obviously important because most people use IntelliJ, and if people are writing macros and they're using Vim, Emacs, ENSIME, they still want those macros to work in IntelliJ for downstream users. So I think it's really important that we all get together and come up with some common tooling there. And it would be brilliant if PC Plod could even be extended to test IntelliJ plugins. I mean, that's something I'd be very excited about. So now's the workshop part. It's your turn. Hopefully, hopefully you've downloaded the project. And it shouldn't have much in it. And the goal of the project is to write an annotation macro or compiler plugin. We have both. You're welcome to try whichever one you want. And use it to replace case class. So I've written a bunch of boilerplate that should get you up and running with a macro or a compiler plugin, whichever one you want. There's 2 folders. It should be easy to find, and a bunch of tests. I think Eugene has a fix for the macro side of it, but we'll leave it as an exercise to the user, unless he's got a PR. But I understand that PCPlod did find a bug in our macro. Is that correct? So it's working. Yeah, so that's basically what we want here, is we want PCPlod to find bugs in your macros and your compiler plugins so that you can make them better so that they work in the IDEs. So if you're implementing case class, we've got tests around implementations of toString, equals, hash code, companion object with apply, which will allow you to perhaps stress out some of the ways of splicing with the various libraries. And you're free to decide whether you want to write raw ASTs or whether you want to use quasi-quotes. I've given a little convenience method in the plugin code, which will dump out the raw AST at the points of the code that haven't been implemented, so you can have a look at exactly what the AST looks like. And that's the way I like to write compiler plugins, is I just dump the whole thing out. You can usually just copy-paste it, shove it back in, and I like to work with the raw AST, so my code's very verbose whenever I write that. I know where I am then. Yeah, that's that. But we'll wait till we get to the wrap-up. The other thing is, if you feel like you're already competent at writing macros or compiler plugins, the other thing you can do is just check out PCPlod and write a test for your library. Make sure that it works. And while you're doing that, myself and Rory will walk around and help. And we'll come back and wrap up in, how long have we got? It says 52 here. I think it's 90 minutes in total, isn't it? So we have, say, 35 minutes. Say half an hour, 30 minutes. And we'll maybe wrap up in 25. 25.
Or pub. You can just go to get some drinks in.
Yeah. We'll see. If everyone sort of naturally wants to move on in 20 minutes, we can cut it short. I mean, the message we wanted to get across, really, was we've got this thing called PCPlod. It can help you write better macros, better compiler plugins. It'll improve things for people using the IDEs. And please get familiar with it, use it. Let's make things better.